and today we have we have the honor to have here Eduardo Ordax. Later, maybe he can introduce himself better than me. So let's start with Ignacy, and he speak a little bit about entity data. Ignacy, it's your turn. Un aplauso. ¿No?
Why are we talking English? Good. So, welcome. Everybody understands English, more or less? Okay. So, welcome everybody. This is Ignacio Aranda. As Irene was introducing me, I'm responsible for the business group here for AWS here in Entity Data. First of all, I would like to say thank you for joining. Well, you might have noticed that we are, that's pretty new. So that's the first day we are opening the Innovation Lab. That's where we co-create with partners and co-innovate also with customers and so community. So that's important for us. So thank you for joining. So second, we are pleased to have we are hosting the user group for AWS again. So that's a pleasure for us, especially because, as you know, AWS is the platform for the builders. So that's important. To us, it's important because that's made for builders. And that connects a lot with what we do with entity data. So basically, in entity data, we work thanks to the builders we have in-house. Without the builders, we would not be doing any business. So that's crucial. And that's the way we connect a lot with AWS. So that's one of the things. The second one, it's how we are connecting here with the topic today. You will see people around from entity data. So you have any question on entity data, and feel free to ask. Have Irene, have also Vero, who is the responsible for the Gen AI AWS offering and so on. So feel free to ask Vero. I hope you enjoy the session. That's how we understand the professional development here in the practice. So we try to keep evolving all the careers of our professionals, and that's a clear example. So we created the first community day in Spain last year. Now we are hosting this, but we will be present also in the community day in Gijón, and we'll be part of a lot of community events. So I hope you enjoy. You feel as being at home. So thank you very much for joining. And now the real star. Eduardo.
Hey, sorry. Can you present? Okay. Can you hear me okay? Okay, let me check if this is going to work because, okay, yeah, it's working. Okay, so thanks a lot for bringing me today here, right? I will try today to talk a bit more about, the practical aspects of generative AI. I know most of the time we are talking about LLMs. Last week, OpenAI, they released O1. Then Anthropic is going to release a new one, and we are having, all the time the same discussion. So I'm going to talk more about how we can leverage the real, power of generative AI, what that it means to move into production. From idea, I'm going to give a bit of, summary, a bit of overview about the different services we have within AWS, but from a practical point of view, right? So for those ones that, or who doesn't know me, my name is Eduardo Ordax. I'm working at AWS for the last couple of years and a half, working for data and AI probably 6-7 years, more data in the past. For those ones that used to say hey, I've been working on AI for the last 10-15 years. It's a fake. I mean, we were not doing any AI 15 years ago, right? So it was all the things about, big data, analytics, and so on. So I work as part of the go-to-market team in EMEA. I'm responsible for Gen AI in EMEA. So that means I'm working with many different customers in EMEA, but also in our other regions. And it's good because we have a good understanding about challenges for the customers. And as I was saying before, the reality is there is quite difference what we are seeing in the media, in Twitter, and all these things about what is the status of generative AI, rather than what is the situation right now. No? I used to start many of my presentations with these slides. Actually, I was posting something before coming here, especially about this, right? So when I'm asking people about which is the status of generative AI, so the reality is like, if we are talking about the hype, we are something here, right? So any technology advancement, we used to draw this, like a curve that is like an S form. So we used to have like very small improvements at the beginning until you reach an inflection point. Then inflection point, you like go on with small improvements and so on. So at some point of time, we can assume the technology has been embedded, is absolutely adopted, and so on. So the reality to generative AI is like, we are actually, regarding to the hype, we are here. Regarding to the capabilities that we have here today, we are some way in between. I will say that we are there. But to be honest, for most of the use cases that I'm seeing from the customers, like I want to implement a chatbot, I want to implement a RAG solution, I want to implement, a classification to differentiate the different intents from the customers. In terms of adoption, the reality is like, we are here. I mean, like, I'm so tired of talking to customers, talking to people. And when you ask them about, hey, how many use cases do you have in production? Which is the value that it's bringing to you? The reality is like, they don't know how to answer because they don't have many use cases in production. Even most of them, they don't have any use case in production. And for many different reasons that we are going to see today, right? But the thing is like, why we are asking all the time, or why we are thinking all the time about if we can go to the moon tomorrow, or even if we can go to Mars tomorrow, if we are not able to go, like just around the corner. So that's the situation. And I'm going to, or at least I will try to explain today, which are the best practices that we need to follow to move into production and to really, like get value from there. And when I was saying that, I mean, like, this is not me like talking like, hey, we are struggling to move into production. We are not getting really value from generative AI. This is based on different reports from Gartner and different analysts, right? And what they were saying is like, they were asking customers like, okay, situation right now regarding to generative AI. Most of them, they are still, like experimenting with generative AI. That makes absolutely sense. But still, I think it was around 50, 60%. Many of them, they are running internal pilots. Many of them about RAG, about, like tools for code development. That completely makes sense to test it internally first. Some pretty risky folks, they are piloting internally. And I think this is a big, like a mistake, to be honest. Sorry, they're piloting externally. I'm not sure if you are familiar with the use case of Ford and Chevrolet, but Ford tried to implement a chatbot to recommend different cars and to solve, like queries from the customers and so on. And at some point of time, the chatbot from Ford is starting to recommend to buy a Chevrolet. I mean, like, if you imagine about, like the brand awareness, this is a big problem. So, I mean, like, I usually don't recommend to start, like by piloting something externally. I was talking to a customer in Spain, big customer. I cannot say the name, but, like most of you so know it for sure. And actually, they want us to start doing this because, like, it's like, hey, we want to say our people, we want to say our customers that we are implementing generative AI. And that's the biggest mistake. Most of the times, even, like, these problems can be solved by the pure use of machine learning models. I remember there were another customer, is for travel and hospitality, and they used to receive emails from their customers to book, for example, a hotel. So they are saying like, okay, I'm here, I need to travel tomorrow, and I want to go from Barcelona to Doha, for example, right? The reality is like, they even didn't need to use generative AI. But the first request from the customer was to say like, okay, we need to say that we are using generative AI. So that's one of the biggest problems that we have today. And I'm not saying like we don't need to use generative AI because they are like amazing use cases, but we need to differentiate when to use it and when to don't use it. The reality is like at the end of the story, only I think it was around 9%, 10% of the customers, they are really moving to production. And this is very similar to traditional ML. I spent the last 3-4 years working on MLOps. And I'm going to talk later a bit more about MLOps. MLOps used to be like a very sexy topic until generative AI arrived. Right now, no one's going to talk about MLOps, right? But I mean, like, the main problem about, or one of the biggest problems that I see is like, because it's super easy to start working with it. I mean, like, everyone right now, it's a prompt engineer. Everyone can talk to an LLM, can say like, okay, act like an expert on, I don't know, medicine, or like doing this, or summarize this document. So it's super easy to work with LLMs. And because we think that it's super easy, all different steps, they are going to be as easy as well. But actually it's not, right? So coming back to the point, I used to work a lot on, like MLOps. And the thing is, like, when MLOps, one of the biggest challenges for customers, it was about deploying ML models. So you take the data, you train a model, I don't know, to detect a customer churn. Super easy scenario, right? So that part, I mean, like, about building the model, the piece of code for, like, predicting if the customer is going to churn or not, it was like super easy. But when they were asking, or when they were trying to productionize these models, they were facing like many different challenges. How to access production data, how to implement CI/CD, how to version your code, how to implement automatic monitoring, many different stuff, right? So they were struggling to move into production. It seems like with generative AI, we don't have that problem. But actually we have. I mean, like, many times we don't need to deploy the model. But this doesn't mean that we don't need to do like many other things, right? And we are going to see it later today. But this is why most of the customers, they are still here, or they are not, like, achieving production, because there are many concepts that they need to pay attention, and they are not there yet. So most of the conversations with the customers, I remember 2 years ago, they were asking about the foundation model. And it was like, we were AWS, we were not OpenAI. OpenAI was working with Azure. And all the customers were asking about, okay, when are you going to have the same model like OpenAI has? Of course, OpenAI was like much ahead to the others. Reality right now is quite different. I mean, like, there is no pretty difference about using Anthropic, about using Mistral, about using OpenAI, Gemini. Actually, for most of the use cases, we are choosing the models in the wrong manner. I mean, like, I would say, like, pretty much most of the use cases that I'm seeing from customers, you can take a simple model, a small model, I don't know, Mistral 7B, Llama 8B. You can fine-tune the model. You can use it for your specific use case. It's going to be cheaper. It's going to be faster. But still, I mean, like, it's much easier to take the Ferrari because we all know that it's going to be super fast, right? So all the conversations were driving around the foundation. We need to see about the art of the possible. I've seen like a lot of, like buzz in media for the last couple of weeks. Well, actually the last week when, like OpenAI, they released this new model, right? And they were saying like, okay, right now we are much closer to achieve human intelligence. Actually, it's PhD intelligence. And this is what, like media and many of these startups, they are trying to make us believe. But actually, it's not important because, again, we don't need this kind of models for 95% of our current use cases. And when we move into production, this is the real story. Probably it's not as sexy as, like as having a nice model like, like, I don't know, Anthropic, whatever. But we need to start thinking about how we are going to manage, how we are going to orchestrate all these different components, right? Hallucinations is something super important for LLMs. And hallucinations is part of how the LLMs has been trained. And we need to give an answer to this, right? Even if we are implementing RAG, I mean, like RAG is much more complicated than just, like trying to convert document into embeddings and find, like the right answer into that. We need to define the right strategy for chunking. We need to implement, or we need to, like take different approaches based on how the documents they are going to look like. Even, like talking about responsible AI, how to manage bias, how to manage, like different ethical risks. Even, like one of the main problems that they have right now is about intellectual property. A few months ago, you were able to prompt the LLM to ask, for example, like, okay, generate an image from yellow people who lives in Springfield. So you were directly not asking to generate the Simpsons, but actually they were giving to you the Simpsons, right? So right now, even for many of the customers, one of the biggest problems when they're trying to move into production is because of that. It's because of the legal aspects. I mean, like if I'm implementing a chatbot, for example, to assist my customers, let's say I'm a financial institution and I want just to implement, like normal queries. Imagine that the customer is going to ask for financial advice. And the chatbot, because, like they always want to give an answer, is going to give financial advice. if something wrong happens, the customer is going, to request the customer to give a solution to them, right? So there are many different ethical risks that we need to manage in some manner. Even data drift, right? This is like an old thing that we used to discuss in the past. With any ML model, we need to monitor all the time the data. If the data is changing over time, probably the ML model is not going to perform well enough, and we need to retrain with new data. I was listening one day, from some folks that they were telling me like, hey, this is a old problem. We don't need to pay attention anymore to the data because we don't have data drift when talking to LLMs. Actually, we have. If we are doing prompt engineering, we are designing the prompts in some manner that we are expecting this kind of inputs. If the kind of inputs is changing over time, our prompts, they are going to be completely useless. And we need to reprompt all my different models, right? How to select a model? Out there, we have around 1,500 different models, right? I'm not talking about proprietary models, but I'm talking about models from Hugging Face. Even, for example, when they released Llama 3, I think a couple of days later, they had 1,000 different versions of Llama 3. Fine-tuned versions of Llama 3, right? So choosing the right model is much complex than just going, through the most powerful one. And most of the times they are doing. And they are doing this because there are two different versions, right? If you are talking to proprietary providers, I've been talking to Anthropic, to AI21, or even OpenAI, and they always tell the same story, right? When you are asking these proprietary providers, they will tell you hey, don't fine-tune the model. It's useless, but it's going to take a lot of time. It's going to take a lot of resources, and then you need to retrain all the time. So you don't need to do that. Just use my model, and it's going to be much easier. In some manner, they are right. But when you go to Hugging Face, what they will tell you is okay, let's take a much smaller model, fine-tune it with your own data, continuous pre-train the model. As soon as you have new data, you can continuous pre-train the model, and you will get a much better performance. Which is better one way or the other? Well, it's going to depend on the use case. But the reality is that we need to assess which model we need to select. So that's why model selection is super important, and it's something that right now, even not many customers they are doing. They're just going through Sonnet 3.5 because they know it's the best model out there, and they know if they are going to use it, for sure, they will give a good solution for the problem. But the thing is okay, can I do it with a smaller model? Much cheaper, much faster? So these are the kind of things that we need to pay attention. Of course, about monitoring, trying to detect toxic content in my prompts, how to detect any kind of attack, how many API call I'm doing to my model, how good or how bad is the performance. There is a huge number of different components that in some manner or the other, we need to orchestrate, we need to manage, because if we are successful managing all of this, our application will go into production. Otherwise, we will have a very nice, a POC that everything belongs to the foundation model, but nothing else than that, right? So I was telling before, when we're trying to productionize things in a reliable, scalable way, we used to talk about MLOps, right? So MLOps is the combination of people, process, and technology to productionize machine learning solutions efficiency. We had the same thing when working with foundation models. So we decided to invent a new concept. Actually, it's not about inventing a new concept. It's because we really need it, right? So we were talking about LLMOps. LLMOps is actually different because the reality is traditional ML in some manner is completely different to generative AI or to LLM. So if we analyze about the different concepts, we will see first of all, the users are different, right? So we may have, for example, in terms of how the process is or how the people is working there, we will have model providers, we will have fine-tuners, and we will have the consumers. And the need for all of them, they are completely different. So for example, and we will see later, providers fine-tuner is more about using MLOps practices. For the last one, for the consumer, is more about using LLMOps. And why LLMOps? Because the way that we interact with this model is different as well. We didn't talk about RAG before. We didn't talk about prompt engineering. We didn't talk about fine-tuning. So we need to implement these practices in a reliable manner that it's going to allow us to move into production. About evaluating these models, it's also a bit tricky because remember with traditional ML, if we were, implementing a model for classification, right? it was pretty simple. False positives, false negatives, true positives. This is the accuracy, this is the recall, this is the precision, end of story. I mean, like, it was super simple to address if the model was performing good or not, right? If we are playing with LLMs, or even if we are building with LLMs, it's not super straightforward. I mean, like, if I'm trying to generate summaries from my data, how good is the answer? Well, it depends, right? And we will see different practices to evaluate the accuracy and the quality of these models, right? As I talked before about evaluating models, model deployment is also very important. And this is, like, the key question here many times when talking to customers. There are, like, different approaches. And even we have, like, different solutions within AWS. We have SageMaker and we have Bedrock. Bedrock is like, I don't want to call it a model hub because it's much more than that, right? But you don't need to deploy the models. The models, they are already there. They are on the like provider account, and you can interact with these models via API. So you don't need to deploy the models. You are going just to pay for input tokens, output tokens. So in some, and it's, of course, it's completely serverless, right? No? So in some manner, you are removing most of the complexity of deploying models. But also you have SageMaker, where you can deploy your own model. And we don't have all the models in Bedrock. So trying to go with one strategy or the other is also very important, because it's going to depend in many different aspects, right? So again, when somebody tells you, like, hey, doesn't make sense to use a model via API because it's super expensive, actually it's not. I mean, if you analyze the cost of token, I mean, like, during the last couple of years, with a unique exception from the release last week from OpenAI, I mean, like, the price is going down dramatically, right? And I think it's going to keep going down dramatically. But again, it depends. I mean, like, for some aspects, probably it makes sense, like, to deploy your own model. For some others, you need to, like, make these API calls. In July, I was in Chile, right? And I was talking to a big university there. And they wanted to use, like, LLMs to assist, well, not customers, to assist the students preparing, like, different learning plans, trying to help them, trying to find what was the right information, and so on and so forth, right? So they were pretty scared to use API calls, because if they had, like, 10,000 students, how much you are going to pay for it? So the cost, it can be, like, dramatically up, right? So they wanted to deploy their solution because at least they have control about how much they're going to spend. So again, there are different, like, pros and cons of using LLMs via API or just deploy your LLMs. Also, deploying LLMs is quite complicated, especially, for example, if you are trying to deploy big LLMs. Trying to deploy Mistral 7B, it's easy. You can allocate it in one single GPU. If you are trying to deploy, for example, Llama 405 billions, it's a completely different story, right? So you need to have the right people, you need to have the right infra, but again, it's much more complex than just going all the time through the same approach, right? So which are the different ways of, like, working with these LLMs right now? I would say there are, like, 4 main categories, or at least I've identified, like, 4 main categories about how you can play with these LLMs, right? More in the left is more about, like, buying solutions, so you don't need to build anything. More in the right is more about trying to build and deploy. And in between, we are going to talk about, like, these different techniques, like prompt engineering, RAG, fine-tuning, the foundation model, and so on. So let's think about, for example, Claude, this application that you can download in your phone, and you can start making questions, doing some prompt engineering. So this is more about, like, using the generative AI application. And this is actually what many of the companies right now, they are trying to do. They are trying to build their own application so the end users, they can use it. Not sure if you have used before Perplexity. I will recommend to take your phone and download it, but I think it's a good example of this, right? So they have built their own application so everyone can use it and they can leverage generative AI, but for the users, it's completely transparent. So it's more about, like, buying something. Amazon Q from AWS is just the application. Then we have the different approaches, like, okay, as I was saying before, and also, like, progress in terms of complexity. If you move more to the right side, it's going to be a bit more complex to build, right? So here you have solutions like, for example, Amazon Bedrock, where you can just interact with the model via API. you can do some kind of prompt engineering, but it's the provider who is going to manage, like your RAG solution, your fine-tune solution. You can fine-tune a model in Bedrock, but actually for you it's completely, like a black box. I mean, like you don't know what's happening behind the scene. You are just giving data and it's going to give you a new model, but you are not doing anything. The same for RAG, right? Then if you need like more ability to customize things, you will go to this approach that is like self-deployment. I will go into SageMaker, I can fine-tune the model, I can implement my own RAG solution, I can implement different techniques like, I don't know, hybrid search, HiD, query routing. I mean, like this is more for builders. But again, it depends on the complexity of the use case. For many of the use case, maybe with this API approach is going to be enough. With many others, we will need to go more into the right side. And yes, on the corner is about, okay, the companies that they need to build their own foundation model. I remember in the past, if you are familiar, like Bloomberg said, like, okay, yeah, it makes sense for us, for example, to build their own model. 2 months later, they realized, like, like GPT was performing much better than that. So when somebody's asking about, okay, that it makes sense to build a model or to train from scratch a model, completely doesn't make sense. But even, like, fine-tune a model from scratch is the same story. It doesn't make sense either. I would recommend like just fine-tune doing LoRa or any of these techniques, but not fine-tuning from scratch. But these are most of the different approaches, and most of the customers, they are like here, right? Even if they are using, for example, Copilot, they are here, just using the application. If they are using Amazon Bedrock, they are here. On the right side, we don't have like many customers yet because of the complexity again. And which is the natural life cycle when we are trying, like, okay, I want to implement, for example, a chatbot to interact with my customers, right? Which is the natural way to work with generative AI? Or at least what should be the best way to start, like addressing how to solve the problem? So my recommendation is to start, like using the LLM as it is. And of course, it depends on complexity, right? Just at the bottom, it's super simple, but probably the performance is not going to be like good enough. If we move up, it's going to require more people, more skills, more cost as well, but the result is going to be much better, right? So if we have a use case, any given use case, we should start by using the LLM as it is. And probably we need to use like the most powerful model out there. Like, for example, okay, let's use Sonnet 3.5, because, okay, if we can, like solve this problem with Sonnet, then we can iterate. Okay, let's go through a smaller model that is going to be cheaper. But at the beginning, we need to prove that we can solve the use case, because in many cases, even, like generative AI is not going to be the solution. So we start by using the model as it is, and then if it's not enough, we can do some prompt engineering. And prompt engineering can be like super complex as well. We can start with single shot, few shot, advanced techniques like, I don't know, self-consistency, chain of thought that everyone is talking about right now, and then you can iterate. So let's say we are still doing prompt engineering and the results, they are not good enough because my model is hallucinating, or because I need to access, I don't know, internal enterprise data, or I need the model to perform in very specific tasks. We need to try different things, right? And RAG is one of the most common use cases. There is also, like a bit of misinformation about RAG. It's not the solution for everything. And sometimes even, like people is comparing RAG against fine-tuning. I think it's not comparable. I mean, like in many different scenarios, we can use RAG, in others fine-tuning, or we can use it both at the same time. It depends on the purpose that we are going to achieve, right? And we'll see later when we need to use RAG, when we need to use fine-tuning. Then, anyway, we can start using RAG, and RAG again can be like super complex. We have like basic RAG. So imagine about, for example, a chatbot that I want to interact with my customers about some information for, I don't know, Q&A, right? So I have a PDF document of 20 pages, I embed the document, I upload into the vector DB, and when I'm asking the chatbot, if the chatbot, it doesn't know the answer, we'll check into the vector DB. But it's super straightforward. I mean, like I'm talking about a PDF or 20 pages, so most of the times it gets the answer, like at the first time. The reality with RAG, it used to be much more complex. I mean, like, if we are talking about trying, like, to incorporate the knowledge base from a customer, that they have thousands of different documents across many different services. Like, okay, I want to embed my SharePoint, I want to embed my Jira, I want to embed my Confluence. I mean, I have the same information in many different formats, many different modes. I may have images, I may have text, I may have like many different stuff, even tables and so on. I mean, like RAG, it can be like super complex. So if I'm asking, for example, like an internal assistant for my employees, and I want to ask for the policy of the paternity or the maternity leave, right? So if you're in Spain, because this is changing over time, so you don't need to give the first answer. You need to give the most accurate answer. And if you find the answer across many different documents, which is the right one? The one that it says the maternity leave is 16 weeks, the one that it says is 10 weeks, the one, yeah, we can use metadata and we can improve it. But I mean, like, these are the kind of things that we need to keep into account, right? Because again, RAG, it can be like super complex, and we'll see later some techniques that it can improve, like the quality of that. That's why basic RAG, I will say, is only for, like demo purposes. Many times when I'm, like talking to people about which is the key to get good results with RAG, when they're trying to implement, like even POCs here or experiments, my recommendation is to start, like with as much data as possible. Of course, you cannot use all the data, but if you're trying to implement a RAG solution, don't start by using only 5% of the data. Maybe go to, I don't know, 30%, 40%, because you are going to get much better results. But again, if basic RAG is not enough, we can start doing, like advanced RAG, and we can talk about, like using agents, we can talk about query routing, we can talk about different techniques that we will see later. And then we can do, like if we want the model to perform a very specific task, like, okay, I want my model, for example, to talk with the tone of my company. So I want the model to answer all the time in some specific manner. I cannot solve that with RAG. And all the models, I mean, like, they have been trained on generic data on the internet. So if I want the model to behave in one specific manner, I need to fine-tune the model. And we have different options to fine-tune the model, right? We can use this API fine-tuning that you can do it with Bedrock. That is like, okay, I have the model, I just admit a bunch of data to the model, I don't know what's happening behind the scene, it's like a black box, and this is going to return a new model that is going to perform better on my data for that specific task. But you don't have control about what's going on there, right? It's not like I'm, like checking the code of the model. I'm going to, like analyzing what's happening across all the weights of my transformer network. So I don't know what's going on there, right? And then you can go up, you can fine tune using PEF, QLoRa, you can do full fine tuning, you can do initial training. But again, these are the natural way, and you need to do trade-offs to analyze, like, okay, do I want to have better performance? I can go up. But again, it's going to be, like much more costly for me. So it depends on what you are trying to achieve. So the purpose for today, and I will go like very much in detail, but trying to solve or trying to give like a bit of information about different services that you can use within AWS to address all these different problems, right? So I was talking before, like the kind of users that we have for generative AI, they are quite different, right? So in the right side, we have the consumers. And the consumers, the reality is like, when I was talking about MLOps, right, they actually don't need MLOps practices. They need LLMOps. I mean, like, these are the people that even they don't need to be like data scientists or data engineers or ML engineers. They're just going to build applications on top of LLMs, right? So if you want to implement a chatbot, if you want to implement a virtual assistant, if you want to implement a tool to summarize tests or whatever, you can be just a software developer that by using generative AI, you are going like to build the application. But it's more about LLMOps. It's more about like how to use RAG, how to fine tune, and so on. If you are a fine tuner or you are a provider, it's more about MLOps. It's about, okay, training a model, labeling data, how to implement CI/CD, how to version my code, all these different practices, right? We are going to focus more today about the consumers because it's more about, okay, how they are going to use generative AI, right? So when we were analyzing, like LLMOps, because, like most of the time we are talking about, like prompt engineers and so on. And this is more about trying to identify the different roles that we need to pay attention when we're trying to implement AI and generative AI at the scale, right? So it's not only about data engineers, it's not only about prompt engineers that right now everyone is talking about. So in the traditional way, when we're talking about, like trying to build any kind of ML model, during experimentation phase, we used to have the data scientists, right? So the same that we used to have data scientists, right now we will have also fine-tuners. For the model build part, we still have, like data scientist fine-tuner, but it's more about, like building a reliable pipeline. Implementing CI/CD, pushing my code, how to implement different, deployment approaches, how to do a canary testing or A/B testing or whatever. So it was more like responsibility for the ML engineer. Then all the model tests and model deployment parts will be automated. And we have, data engineers, data owners of the data side. We have, the MLOps engineers that they are going to administer the platform. Because, of course, this is super important. I mean, like right now, we are not talking a lot about how to implement platforms. But you guys here from Entity Data, I'm pretty sure you know, like any customer that they are trying to scale the use of generative AI, I mean, like, this is not about building one single isolated use case. It's not about building a RAG application. It's about building multiple use cases in production. And for those ones, they are going to invest a lot of money on the platform. How to access your production data, how to give permissions to the different users, how to create an environment when they can collaborate, and so on, right? So the platform part is going to be like a super important as well. And then you have the application layer. And the application layer is more about, software developers, generative AI developers, product engineers, and so on. But we need to keep in mind all these roles, and even taking into account that maybe the same person can implement different personas, but it still is something that we need to do, to be honest. So let's focus a bit about the journey that I was talking about, right? Like, okay, I'm going to do prompt engineering, I'm going to do RAG, I'm going to do fine-tuning, how to select a model, how to validate a model. So these are the kind of things that Bedrock is trying to do, right? So many months ago, I think it was like April 2023, when OpenAI, they were working with Azure and ChatGPT, and Google was working with Gemini. Well, I think by that time, even they were not working with Gemini. We decided to take a different approach, right? In some manner, we understood that at some point of times, LLMs or foundation models, they are going to be a commodity. It's not like they are a commodity, but in some manner there are. I mean, like right now, as I was saying before, there are like many different models at the same level. There is not huge difference about using one model or the other. And actually, if you ask people, they prefer, for example, to use a model for code, a different model for summaries, a different model for RAG, a different model for a different thing, right? So depending on the use case, you prefer to select one model or the other, right? So by that time, we understood that it was actually a different approach, the one that we were going to take. I mean, like it was not about training model from scratch, that of course we have some models that in Bedrock, like the Titan family, but it was more about, okay, we want to provide a tool, we want to provide a platform that is going to allow customers to scale. So you can access different models, but we will give the tools to play and to work with these different models, right? So we are going to give tools, for example, to evaluate the model, to implement RAG, to fine tune, and so on. And let's make it like super simple, because even right now with Bedrock, as I was saying before, you don't need even to be a data scientist. Anyone who has a bit of, knowledge about coding and so on, can, build their own applications. So this is how the journey looks like, right? So first of all, we need to select the model. We need to evaluate it. And first of all, we need to define like, okay, I'm going to do fine tuning, I'm going to do prompting, I'm going to do RAG. Then I will integrate it. Even I can execute actions, right? I can implement agents. And, the last thing that I will do is to monitor my application. So if we focus on model selection, right? I was saying like, I think in Hugging Face, you have around, I think it was like 15,000 models. I think it was something like that, right? The thing is like, this is much more than just trying to decide across 3 or 4 models. That this is what is happening right now all the time. It's about, okay, I'm selecting GPT, I'm selecting Sonnet, I'm selecting Gemini, or I'm selecting Mistral Large, for example, right? So there are like many different models out there. So which is the recommendation, or how should we start, to decide which is the best model? So first of all, it's about trying to understand the main difference, right, between open source, proprietary, but also about the use cases. Because for some use cases, it's better one model. For some others, it's better a different model, right? So I try to define, or I try to draw like a framework to select across many different models. And which is the way to go, right? Or which should be the first steps that you need to take when selecting a model. So first of all, it's about the modality, right? And maybe it may seem pretty obvious, but actually it's not. I mean, like if I'm talking only about text, I will only select like a model for text. If I need to include audio, video, whatever, right? So first of all, it's about the modality. Then I need to think about the use case. If it's for text, I mean, like there are many different use cases for text. I mean, like there are some specific models, like the ones for Cohere, that they are working super well, you know, trying to retrieve information. But we have others that for conversations can be also very good, like for example, Llama, that they were trained specifically to follow conversations, right? So we need to analyze as well the use case. Then we need to know how they have been trained. I mean, like for example, if I want to fine-tune a model, let's take a base model. I mean, like I cannot fine-tune a model that has been fine-tuned before, right? Language is also another important aspect, especially in countries like here, Spain, right? So many of these models has been trained like 90% in English, but they are not so good, for example, talking Spanish. I mean, like they can understand, but they are not like good enough. For example, Llama 3 is a good example. If you go to any, you know, like leaderboard on model performance, I think Llama 3.1, it was like top 2, top 3 most of the time for English. If you were analyzing for Spanish, I think it was like even not in the top 10. And if you want a good model for Spanish, my recommendation is like either you go with Anthropic or OpenAI or any of these models, or you fine-tune your own model with your own language, because otherwise it's going to be challenging. And even we are talking about the Spanish, let's imagine when, you know, like you go to different places and you go, for example, because I was last week in the Netherlands, I mean, like how they are going to perform talking in Dutch. Or even here in Spain, talking, you know, like in different languages, like here in Catalonia or Galicia or whatever, right? So, I mean, like they can understand, they can talk, but they are not like as good as talking Spanish. And this is like super important, right? So this is something that we need to keep in mind. Also about open source, closed source, open weights, and so on, right? So, and I think this is an important point, because I used to hear like many times like, okay, this is free because it's open source, so let's use Llama because it's open source, it's free. Well, actually it's not free. I mean, like we can have, you know, like the false assumption that using Llama is going to be free for everyone. It's going to be free for everyone. But actually, I mean, like if you are using Llama via API, you need to still pay the price per token. I mean, like it's not free. Or even if you want to deploy Llama, you need to pay for the GPUs. I mean, like the GPUs, they're not free either. So there is not a big difference in terms of cost, right? So, I mean, and I'm a big defender of open source and so on. But again, we need to keep, you know, like all the difference, right? So when we're talking about proprietary models, right? Proprietary models, we don't have access to the code. We don't have access to the weights, so we cannot fine-tune them. This is not exactly true, because we can fine-tune right now, you can fine-tune Haiku, you can fine-tune even GPT, but as I said before, it's like a black box, right? You are just sending data, they generate a new version, but you don't know what's happening behind the scenes, right? Anyway, you don't have access to the data, you don't have access to the training data, you don't have access to the training data, you don't have access to the code of the model, you don't have access to the weights. It's a proprietary model. And even you don't own the model. I mean, like the model is deployed in the account from the provider. If you are using Bedrock, the model is not in your account. It's in the account of the provider. That's super important. I mean, like you cannot take the model and download the model. You can do that with open source on open weights. Which is the main difference between open source, open weights? Open weights is Llama, it's open weights, right? Mistral is open weights. So essentially, you can download the model. You can fine-tune the model because you have access to the different weights, right? So you can generate a new version of the model, but still you don't have access to the training data. So if the model is biased or is, you know, like answering in some specific manner, you don't have access to the training data, and you don't have access to the code either. I mean, like you cannot go to the code and modify the model, but still you can download it. And of course you have some kind of, you know, like requirements in terms of how you are going to use the model, in terms of the licensing, right? So if you are using Llama, for example, let's say you are implementing a virtual assistant in your website, you are company X and you are building this virtual assistant, you need to specifically say this virtual assistant is powered by Llama, and depending on the number of users you're going to have, you may have to pay or not, right? So these are the main difference. Open source, you can download, you have access to the weights, you have access to the training data, you have access to the code. Essentially, you can take it and do whatever you want to with that. For most of the use cases, open weights, open source is pretty much the same. That's the reality. So you need to select which approach are you going to take, but also the problem with proprietary models is like if you are using one model, these models, they're not going to be there all the time. They're going to be deprecating over time. I mean, like right now, for example, it doesn't make sense to use Claude Instant. I mean, like because we have much better models and cheaper models. What happens if my application was built on top of Claude Instant? And AWS is going to deprecate it because it doesn't make sense. So we need to migrate my application into a new model. So you need to live with these kind of caveats, right? If you have your open source model that you have deployed in your infra, I mean, like, it's not a problem. You just continuous pre-train based on new data, but you never have this problem. Of course, the reality right now is a bit different. I mean, like, migrating from different versions within the same family is much easier. I mean, like, if you need to migrate from Claude Instant into Claude 2, from Claude 2 into Claude 3, I mean, like, migrating from Claude 3 Sonnet into Claude 3.5 Sonnet, you almost don't have to do anything. You still need to do some tweaking, but it's like pretty straightforward, right? When you have your own model, you don't need to do that. So right now also, the situation is a bit different. For many customers, it's like, okay, do I want to use always the same family of models? Because yeah, if you need to migrate from Meta into Claude, or from Claude into Meta, or from OpenAI into Claude, it's going to require much more work. So these are the kind of things that we need to consider. And at the end, for me, these are, well, for me, in general, these are the most important aspects that we need to keep in mind, right? So size of the model. When I'm talking about the size of the model, it's more about, the complexity of the model. I mean, like, bigger models, at the end of the day, they're going to have more latency. They're going to be, much slower. And this is a problem. I mean, like, if I want to have like a good customer experience and they're expecting to have an answer, in real time, they cannot use a model that is saying all the time, like, okay, I'm thinking, 20 seconds, 30 seconds, I'm thinking. So they're expecting, like an immediate responses, right? So it's about latency. It's about cost. Many use cases I've seen, they needed to come back to take a different approach because it was like super expensive. I remember a company in the UK, they wanted to use it. Well, it was a complex use case. They also were generating images and so on. But I mean, like, the cost of using LLMs, it was much more expensive than just using humans. And in this case, it didn't make sense, right? So you need to analyze the use case. You can, use different approaches in terms of, okay, the context window is also important, the quality of the model, it can be fine-tuned or not. So at the end, you need to do some trade-offs. And based on this, you will select one model or the other. My recommendation is like, based on this, you can select, 3 to 5 models, and then you are here, right? You have this quick sort list that you are going to test it with different, testing prompts that you may have in Amazon Bedrock. In Amazon Bedrock, we'll see later, you have model evaluation. As soon as you have your 4 or 5 different models, you just submit your test prompts, and you can select, which is going to be the best one, right? So at the end of the day, based on that benchmarks, you will select based on cost, based on latency, and based on performance, as we are going to see right now. These are the different foundation models. I'm not sure if this is updated because this is changing over time very often, right? But when we released Bedrock, the main goal, it was to have, the best models out there, just, accessible via API. So right now we could say like the top model providers, of course, with the exception of, Google and OpenAI, they're available in Bedrock. We have AI21. AI21 is a startup from Israel that they have created this new architecture that is called Mamba. They just released Jamba 1.5 a couple of weeks ago. You have our own family of foundation models, the Titan models, right? And we have for images, embeddings, and so on. Anthropic models, probably we will release, or they will release by the end of this year, Claude 3.5 Opus, Claude 3.5 Haiku. They will be, also fighting against OpenAI all the time. You have the family of Cohere models. Cohere models that are especially good for, RAG things. Even you have, sorry. You have the ranker model from Cohere to rank, different. When you are, retrieving the chunks, you can re-rank the chunks to get the best one for your answer. You have the models from Meta, Mistral, Stability. I mean, Bedrock, it tries to collect, the best models in the market, and it's, continuously updating new models as soon as they are coming out. For example, as soon as Llama 3.5 was released, the same day was available in Bedrock. The same for Mistral, the same for Cohere, Anthropic, and so on. But as I was saying before, once you have all different models, you need to evaluate them, right? And evaluating LLMs is not as straightforward as evaluating, traditional ML models. So you have different approaches, right? First of all, we need to ask, do we have the ground truth of the model? I mean, do we know what we're expecting for? I mean, if we have the ground truth, more or less it's simple, right? So if it's more about a classification problem that we're expecting to have discrete outputs, it's super simple. It's the same like traditional ML, right? So it's okay, recall, precision. So let's say okay, I'm asking who is the president of Denmark? We have the label output. The president of Denmark, well, the king of Denmark, it's Frederick X. So we compare the output, we compare the data set, 1.0 precision. Super simple. What that it happens if we don't have these discrete outputs? Okay, I want to write the summary of this text, right? So we need to start using different metrics like Helm, distance, rooks, perplexity. These are different metrics that they are trying to evaluate, for example, the quality of the tokens that the models they are predicting, right? So you have the summary, you have the label output, and you are going to start getting different metrics. And the metrics, I mean, we are not just managing one simple metric. We are managing different metrics, and based on that, we need to select one model or the other. If we don't have the ground truth, and this is what is happening right now for most of the use cases, you have two different options. If you want to automate the process, you will use another LLM. You will use this LLM use or LLM evaluator, when we can use another LLM to evaluate the quality of the model. It may sound a bit tricky, but the reality is this model has been trained specifically for this, and it's working pretty well. So for example, with Bedrock, you have a LLMs evaluator that they are going to give you information about how good or how bad is the model. And the last option that probably is the best one out there, I mean, is the one that is going to give you the best quality output in the evaluation, but it takes a lot of time and it's super expensive. It's about, using human in the loop. It's about using people to evaluate, okay, from 1 to 5, or, thumbs up, thumbs down. You can evaluate the quality of the model. So based on this, you are going to get these different parameters, right? You are going to analyze the precision of the model. Either it's Helm, rooks, whatever, but you are going to analyze the precision of the model. You are going to analyze the speed, and you are going to analyze the cost. And you will, we'll see with the use case, which is better for you. If we want to prioritize cost, we'll go with an option. If we want to prioritize speed, we'll go with another option. Or if we want to prioritize, precision, we'll go with the other. So to evaluate LLMs in Bedrock, it's super simple. You have different options. You have the playground, but even you're more in a production environment, you have a programmatic approach where you can bring your own data set, you can bring your own prompts, and you can, even they already have a specific curated prompts where you can use to evaluate the model. So if you are using, for example, you want to test for one specific use case, Sonnet against Meta against Mistral, you just put the three models competing against each other, and you're going to see the results. And based on that, you will select one model or the other. But I mean, you can use human in the loop with model evaluation. So you can bring your own workforce, or you can use the one from AWS, and you can start assessing, how good or how bad is the model. So these kind of tools like model evaluation is going to accelerate the way that you are evaluating and you are comparing model. Because even right now, in many cases, it was a bit, not very programmatic. I mean, it was pretty manual, okay, I think this model is performing better than the other, but it was not something that you need to do, right? which are the different options to consume LLMs? I was saying before, like you can deploy your own model. You just book the number of GPUs that you need. Okay, I need this P5 GPUs. I will pay, like price per hour of GPU consumption, or you can use the Models V API. But even using the Models V API, you have different approaches. You can do what it calls like on demand or pay as you go. Number of tokens, number input tokens, number output tokens, you are going to pay for that. But for many specific use cases, when you need to have like a good user experience, you can go what we call like provision throughput. Provision throughput, yes, in a very easy manner, is like we are receiving something like it's called model units. So for these customers, all these model units, they're going to be reserved only for you. The thing is like either you use it or not, you are going to pay for it, because these models, they are going to be only for you. Of course, in terms of pricing, is much better. I mean, like, you can get like much lower prices, but again, you have to pay for it either if you use it or not. But this is more like a commercial offer, so you are aware about that. And then, as we said, you have different options, right? You can do fine-tuning, you can do prompt engineering, you can do RAG. So fine-tuning, RAG, which is better, one or the other? It depends. I mean, like, if you want to augment the knowledge of my LLM, I will go into RAG. If I want to optimize my LLM to perform very specific tasks, I will go through fine-tuning. So when somebody is saying to you like, hey, don't fine-tune a model, just use RAG, they're just lying. I mean, like, it depends. It depends on the use case, right? In many use cases, I've seen like using fine-tuning and RAG at the same time. So naturally, as I said before, you start with some prompt engineering techniques, you evaluate the output, the quality of the output, and then you can, like, start iterating. Okay, I can do some RAG, I can do some fine-tuning. So as I was saying, for example, LexisNexis is one of our examples of customers. LexisNexis is an application, it's like a RAG application actually for, like, analyzing legal documents. So one of the problems of LLMs is that they have been trained on general data on the internet. They are not good at law, they are not good at science, they are not good at medicine, they are just, like a generalistic models. So this application, it was specifically to analyze laws from many different countries. That's why they had to do, like, from one side RAG, because they need to check different documents, but they also need to have the knowledge about, like, law concepts. So if they are talking in one specific language, they need to understand. I mean, like, the kind of language that the doctor is going to use is quite different, like an informal discussion, right? So this is what we are trying to achieve with fine-tuning. We can educate the model to perform super well in some specific task. I used to use this example. Let's say I'm going to an exam, right? I don't know the answer. So because I don't know the answer, the teacher says to me like, okay, it's fine. You can open the book. You can find for the answer and let's copy into the exam. This is RAG. I mean, like, maybe I don't have any idea about what I'm copying from the book, but I mean, like, more or less, I can go through the book, find the answer and copy that. If the teacher is not asking me about copying the answer, it's about, okay, explaining to me how this is going to work, I need to understand. I mean, like, I need to read the book, I need to understand the book, and then I need to give an answer to the teacher, right? So this is fine-tuning. This is when a model is going to understand and is going to perform well in this very specific task, but because, like, I'm aware of the different, like, concepts that I'm trying to learn about. That's why I'm saying, like, hey, fine-tuning, RAG, there are different options. Most of the time they are saying like, hey, RAG, it's super easy, let's do RAG. Again, it depends. Yeah, it's easy on experimentation, basic RAG. Advanced RAG, it's a different story. And prompt is the same. Crafting prompts or doing prompt engineering is much more than crafting prompts, right? We are talking pretty much about prompt and not a lot about the engineering part. And prompt engineering should go together. And why I'm saying this, right? It seems like today everyone can be a prompt engineer. In some manner can be, but as I said, it can be super complex. I mean, like, for me, prompts or prompt engineering is like writing code. I mean, like, when you are writing code, you have your, your GitHub repository, you are versioning your code, you are pushing your code to production, you are tracking the results, you are comparing the results. you are doing pretty much all these things, right? So with prompt engineering, it should be the same. If I'm changing a prompt, I need to analyze the results. I need to compare it. I need to version my prompts. I mean, like, one of the main problems with prompts or with LLMs is because they are non-deterministic. So with the same input, I can get many different answers, right? So that's why it's super important to do all these kind of things, right? So even for creating prompts, the reality is like, we are never starting from scratch. Maybe for one use case, we are starting from scratch, but any single customer right now, they have different prompt templates that they can, like, reuse for different purposes, because I want the output of my LLM to follow this specific structure, or I want to generate a JSON file. So, I mean, like, it has some concepts that make it, like, to take a more formalized approach, right? So when we're talking about prompt engineering, we should pay attention to all these different concepts. I've seen customers, like, storing prompts in Excel files. That is not, of course, a very good practice, right? So this is why when we create Amazon Bedrock, we also try to provide solutions to do, like, all these different aspects. So with prompt flows and prompt management in Amazon Bedrock, you can have different templates. So if you are building a bot or an assistant or a RAG solution, you are not starting from scratch. If you want your documents to be generating one specific manner, you can follow your prompts. In a very visual manner, you can, like, change different prompts, or you can say, like, okay, the output of this prompt is going to go into this, or it's going to spin up, or it's going to call a lambda function. So in a very easy manner, you can, like, describe the flow, and you can see all the dependencies from the different prompts, right? You can version the prompts, you can test your prompts, you can deploy your prompts, and you can monitor, like, the results of the prompts. So it's going to make your life much easier when doing prompt engineering. And actually, it's already I think it's in GA already. I'm not pretty sure. I think it's in GA. But again, I think it's, like, super nice, because it's making your life much easier when doing prompt engineering. As I was saying before, I'm not going to talk about, like, the different services we have for RAG at AWS, but we used to think about RAG like this, right? So I have my documents. I convert my documents into embeddings, because it's the only way that LLMs can understand, like, how to talk to them. I generate embeddings, and I store the embeddings in my vector database. Even it cannot be like a vector DB. It can be like a pure SQL database with, like, ability to store vectors as well. So how RAG works? If I'm, like, the user, I make a query. I transform my query into embeddings. So the LLM understand that they don't know the answer, and they need to retrieve the answer from the vector DB. I get the answer, I augment the answer to the query, end of story. So we used to think as RAG is something simple like this one, but again, it's much more complex. I don't think we're going to be in time to go through all different concepts, but most of the times, like, RAG is even not about the LLM that I'm going to select. It's not even about the complexity of the technique. It's about the first single step, that is about how I'm going to create the chunks of my documents. The chunk is the, like, the different parts of the documents that I'm going to, like, vectorize to convert into embeddings. And there are, like, many different approaches. And some of them are already, like, available to do in Bedrock. But you can do just chunking in the most basic way. I have the documents, and I'm going to chunk my documents into fixed chunks, right? So regardless of the documents, regardless of the structure, I'm, like, converting the chunks in the same way all the time. I can do the same, but with some overlapping to keep the context. Let's say, like, okay, I don't want to cut, for example, a word in the middle, so I want to keep some overlapping, because it's going to be, like, much easier when I'm trying to retrieve. I can keep, like, the structure of my documents. I can do chunking by, I don't know, by paragraphs or chapters or sentences or sections. I can do recursive chunk, like, okay, I'm going to do small chunks, and then, you know, like, I'm going to keep the parents of the chunks, the grandparent of the chunks in a hierarchical manner. So when I'm finding, or when I'm trying, you know, like, to retrieve, I will go into this, and then I will retrieve the parent, the grandparent. I can also do chunking based on, you know, like, different elements, if it's like an HTML document, latex, wherever. And one of the things that usually work much better, that completely makes sense, is to do chunking by the semantic style. I mean, like, if I have a document, I will keep the semantic meaning of my document. I don't want to cut, for example, a paragraph if it makes sense to do like 2 chunks or 3 chunks. The problem about this is like it's super expensive and it's not working well all the time. But what I mean, like when I'm doing RAG, I shouldn't go through this all the time. I need to analyze which is the strategy to do chunks. Right now with Bedrock, we have semantic chunks, we have fixed with overlapping. I think we also have about, you know, like the extractor aware. Again, just to keep in mind that this is super important. What else? Yes, you know, like very high level, different options for doing RAG. Remember the example, if I'm asking for the paternity leave policy for my company. So when using RAG, we can use also metadata. If I'm asking this question, probably I will say like, okay, let's use metadata just to retrieve the latest document about the paternity leave policy. In this manner, I will get much better result, right? So we can use metadata to increase the accuracy of my results. So as soon as I'm making the query and I retrieve the documents, or the documents, or with the chunks, I will use the metadata to do like a filtering. This is one of the most popular ways. The other option is re-ranking. So when we are using RAG, again, we used to retrieve the top key documents or the top key chunks, right? So I'm making the question and I retrieve, I don't know, 4 or 5 different top key chunks. Something that I can do is to use LLM that is going to work as a ranker. So it's going to say, okay, in this order, this is, you know, like the one that it has more relevance to your input query. So you can compare the question from the user to the chunk that it was retrieved. You analyze the relevance, and this is the one that is going to put you like in first position. You can, if you use like hierarchical chunking, you can use this like, okay, I'm going to retrieve only, you know, like the son of the chunk, and then I go into the parent, to the grandparent, and so on. I can use something that is called query rewriting or query transformation. So when I'm, you know, like using a virtual assistant, a chatbot, wherever, one of the main problems is like, we are not good making questions, or we are not good, you know, like talking to the assistant. So we can use an LLM to rewrite the way that we are asking. So if I want to ask, for example, as I said before, I want to know the maternity leave policy. This LLM is going to rewrite my question, so it's going to analyze, okay, this user wants to know about this, so it will rewrite the question, and then it's going to be much easier to compare across different options. So it's just about using another LLM to rewrite the previous question. Of course, we need to know that this is going to include latency, it's going to include cost, it's going to include complexity, but of course, we are going to get, you know, like a much better response, or, you know, like a much better, or it will increase the accuracy of my answer. We can do something that is called about, you know, like hierarchical index. So this is good, especially when we have like, I don't know, thousands of different documents. If we have thousands of different documents, instead of, you know, like searching by the different chunks that you have, you know, like millions of chunks, we can do like something that is called an index of summary vectors. So at the beginning, when I'm doing the chunking, I can summarize the different documents. So instead of searching against the chunks, I'm searching against the summary. So it's like 2 different steps. First, I search against the summary. So it's much better to compare, I don't know, 100 summaries rather than comparing, I don't know, 10,000 chunks. So I search in a first step, and then I will look into the different options for each summary. Another one is for sentence window retrieval. This is especially if you made the chunks based on sentence, so you don't retrieve only this sentence, but also, you know, like the other sentence behind the chunks. Chat engine context, especially for assistant, chatbots, where you don't want to use only the query from the user, but you want to include all the context from the conversation. This is actually what, like even OpenAI, Claude, they are doing. They keep a history of the conversation. So if you are asking them, it's when you like to recover all the history so it can perform much, much better. Query routing. So this is also pretty much to LLM routing. It's about, like when you have an LLM at the beginning that is going to select which is the best approach. So they can say like, okay, a best approach is, like to go through the index summary. Another approach is to do like a re-ranker. So it's like using LLM to route through the best different options. So you can even implement 10 different techniques with RAG, and you use this intelligent LLM to decide which way to go. HiDE is about, this is also pretty nice. Is instead of searching against the chunks, when I'm doing the chunking, I'm generating, for each chunks, I'm generating a question. So if I'm talking about, I don't know, these chunks is about, as I said before, maternity leave policy. I'm creating the embeddings for the maternity leave policy, and I'm creating another embedding that is going to say, can you tell me about the maternity leave? So instead of searching against the chunks, I'm searching against the question, because it's easier to search, like question compared to question. This is HiDE. This is hybrid search as well. In some aspects, we want to search for the semantic meaning. In some others, it's more about keyword matching, right? So you implement both approaches at the same time, and you decide which one is better. You can use agents with RAG. So there are multiple techniques for RAG. These are just an example of the most important ones. And all the things that we have seen before, you can complement it. You can use query rewriting with HiDE. You can use query rewriting with hybrid search. You can use all of them as well with re-ranker. So, I mean, again, it can be like super complex. That's why what I was saying, like, hey, RAG, yeah, it's easy to implement. Advanced RAG, it's a different story. With Amazon Bedrock, we have different solutions for RAG, but we have knowledge base that is a completely managed solution to implement RAG. So knowledge base with Amazon Bedrock is going to allow you to implement in a very easy manner, or to create all your chunks with the different strategies. As we have, you can implement different ways to search against the chunks. We can do semantic search, we can do hybrid, we can do HiDE. So it's going to give you the tools to do this RAG solution in a very modular manner. So for like most of the customers, this will be more than enough. For many other customers that they may have like very complex solutions, or they need to have like more customization options, they need to go through like more like a build by yourself. But again, in most of the cases, it's working. And finally, and very briefly, right, you can also do fine-tuning and continuous pre-training in Bedrock. And just to understand the difference, because sometimes they are using the same manner, actually it's different. So fine-tuning, it requires label data. It used to have like, like paired data of prompts and user output. So if you want the model to perform very specific tasks, I will give you like an example of label data, like, okay, this is the input, this is the output, this is the input, this is the output. And you can submit into Bedrock, and as I said, like a black box is going to generate a new version of the model. But we also have something that is called continuous pre-training. Actually, continuous pre-training, it must be called, or it may be called like fine-tuning, but it's a specific thing. Because continuous pre-training, you just need just unlabeled data. This is more about knowing about a specific language. If we want to know about medicine, if we want to know about laws, but let's say like I want to create a chatbot to talk in Basque, for example, in Euskera, right? So you can submit a lot of unlabeled data of conversations from this minority language, and you are going to make the model that is going to perform much better, right? So these are the different options that you have in Bedrock. Which is the best way to go? Do I have to do prompt engineering? Do I have to do RAG? Do I have to do fine-tuning? As I said, it depends. I usually say like, you always get the best results when you do all of them, but again, it's going to take some time, and it's going to take, some complexity, some skills. So depending what you are trying to achieve. If you want just to reduce hallucinations, maybe RAG is more than enough, right? But if you want to, instruct the model to perform a specific task, you need to go with fine-tuning. If you need to go with a flexible approach, quick approach, very cheap approach, let's do just prompt engineering. So you need to do some trade-offs, and based on that, you need to define which way to take. I saw you taking pictures. I will share the presentation with you. Don't have any problem. I will share it with you, and you can have all these things in a very easy manner. And finally, you need to monitor the application. And about monitoring, it involves many different components, right? We have about functional monitoring, number of requests, which is the usage of tokens, which is the latency, how many errors I'm getting per request. So this is something that it's more about your application, right? Monitoring the responses. So we need to analyze the relevance of the output. Are we generating as well, a toxic content, not toxic content? Are we having kind of prompt injection? We also need to monitor the quality of the prompts, and we need to define, alerting, threshold. So monitoring LLMs, I would say, is quite a complex topics, because there are many things that we need to analyze. It's more about the application, but it's also about the relevance of the output, to make sure that we are not generating this kind of toxic content that can create problems for our brand. So again, we need to implement different tools. We already have different tools on Bedrock to analyze that, but it's super important to define how the flow is going to be, and to make sure that we can analyze, the input prompts. They are, being modified over time, the quality of our outputs, and so on, right? So again, another important aspects, and this is pretty much about, the user for the consumers. If we go to the providers, I will go very easily about the providers and the fine-tuners, but this is most about, traditional ML. I don't care if it's a model to predict churn, or it's about, creating a model from scratch. The life cycle is pretty much the same. It's about ingesting data, cleaning data, labeling data, doing feature engineering, doing distribute training. But again, it's more about, deploying LLMs or deploying, foundation models. For the fine-tuners, it's pretty much the same. This is what I say, consumers, fine-tuners, providers, they have quite different needs and so on. Very briefly, these are, the different services that we have. So when I was talking about, fine-tuners, providers, consumers, this is why I tell you, right? If we are talking about, producers of LLMs, we are talking about, using GPU, SageMaker, people that they want to train their model from scratch. If we are talking about consumers, it's more about Bedrock, right? I want to create new applications on top of these LLMs. If we are talking about the end users, I'm talking about the user who is going to use, Amazon Q, the one who is using ChatGPT. They don't need to have any kind of knowledge about generative AI, but they can use these applications. I want to generate my avatar. So I don't have any idea about how diffusion models works, but I can just upload some pictures of me, and I won't create a new avatar. So what I'm expecting to see very soon, and this is just 2 more slides, I promise. So, especially because we are in Europe and we love to regulate stuff, I have my own opinion about that, but because you are recording, I cannot say it, so I can say later about this. But we are expecting to see a lot of regulation, especially in the European Union, about how we can use these models. Of course, in other countries or regions, they are much more open. If you are familiar, for example, with Grok, not the chips, but the model that it has been created by Elon Musk, it's super open. You can create almost everything you want. It has, of course, its implications, but of course, we will see many different aspects here in Europe with the EU AI Act, and in some manner, they need to regulate this stuff. Model routing, as soon as we have more models, we need to select the best model for my use case. And the reality is even not for the use case, but it's for the user input. So I'm expecting to start using model routing a lot. If I'm asking a question, and I'm going to, like, talk about myself, how we operate as humans, right? So if you're asking me something simple, I'm not going to think a lot. I will just give you an answer. So it's like, okay, how much it is 2 plus 2? Okay, it's 4. I don't need to think. But if you are, like, giving to me a complex problem, I will need to take my time, right? So this is the same that we are doing with model routing. For a specific task, we may send the task for a simple model, for some others to another model. Even within the same use case, we are going to use different models. All models, they are going to be multimodals because this is the way that we operate. So they need to understand image, video, audio, whatever. We will start seeing more and more use cases about, like agentic. There are like different patterns about how to use agents. We can talk about self-reflection, tool use, planning. But again, I think this is something that we are going to see more and more because it's the way how we can automate tasks, right? AI is going to be almost everywhere. Small models, they are already, like, starting to be something that is pretty much used. As I said before, it makes more sense to use a much smaller model for one specific use case. Open source, 12 months ago, open source were like quite behind proprietary models. Right now, Llama, Grok, they are the same level, even Mistral, right? So I don't think right now there is a big difference between proprietary and open source. And I think this is great because, like, there is a huge community building on top of the open source. And yeah, for sure, we will start, like, keep seeing this battle between OpenAI, Anthropic, Meta, about who is going to be able to create the best model. And I think that's good because, like, even with the latest model from OpenAI, that they are actually doing, well, they are, like, this chain of thought part, like, they are running inference, like, they are running testing during the inference part. I mean, like, it's a completely new approach. So I think that's good because, like, they are, like, pushing each other to create new and new or better and better models. My own opinion is, like, if we keep working on the same architecture, like the transformer architecture, I don't think we are going to go too far. And, like, it requires to go with different approaches. Takeaways for today. As I said, we are talking most of the times about LLMs and so on. The reality right now is we are in the very early days. When you look into the customers, they are not like very cool stuff, fancy examples. All of them, they are still experimenting. We need to start thinking about, okay, how we can bring real value from generative AI, right? Second thing, LLMs, remember the first picture at the beginning, they are just a very simple and small piece of the whole ecosystem. How to orchestrate all together is going to be the key. There is no one single model that is going to rule them all. I mean, like, we have many different models, many different providers. So right now it's about flexibility, how to use one or the other. People, it's super important. I've seen, like, many customers trying to build stuff with still the same people. When we are talking about prompt engineering, or we are talking about RAG, it requires a specific skill. So I always recommend to, like, invest on your people. I'm not sure if it's about hiring or if it's about enablement, but it requires to take some time. And again, this is super important. And again, I'm field defender about, like, prompt engineering. Let's do more engineering and less prompt because 90% of the use cases right now you can solve it with prompt engineering, but prompt engineering, we need to do it in the right manner. So thanks a lot. I hope you enjoyed and at least you took some good insights for today. Thanks.